Okay, this is Matt 1140. These are the chapter 17.4 notes. These notes are just volume. Now, volume is the space that something holds. So it's the amount of interior space for a figure. And so when we talk about interior space, we're talking about a three-dimensional object. Okay? So we have two things that we want to make sure we understand what the difference is. A prism is going to be a three-dimensional figure that has got a polygonal base, which means it's a shape with straight line sides. So a triangle, a square, a hexagon, an octagon. It can be some other bizarre shape as long as all the sides are straight lines. Polygon. A cylinder has a circular base. So soda can, Pringles can, that's what we mean when we say cylinder. Volume is always going to be found the same way. It is going to be the area of the base times the height. So this capital B you see here in the formula, that is the area of the base. I realize it says that below. So the area of the base times the height of the shape. Okay. So let's take a look at example 1. We have a triangular prism, which means the base is a triangle. Okay. And we have a picture here so we can see the height of the prism is 15 centimeters. The triangle has 3 centimeter sides with a 2.6 centimeter height, so be careful. This has to do with the triangle. So we're going to find the area of the base, 1/2 the base times the height. Now be careful. Capital B is the total area of the triangle. That's our base. Little b is the base of the triangle. So I have 1/2 times the base, 3 centimeters on each side, times the height. When we multiply those together and then divide by 2 or multiply by 1/2, however you're doing it, we get an area of the base of 3.9 centimeters squared. And I'm going to add that in here, the label, so that when we find the volume, it makes sense. Volume is the area of the base times the height. Here I have 3.9, again, centimeters squared, times my height is 15 centimeters. I'm doing that because I want it to be clear where that centimeters cubed is coming from. So when we multiply the numbers together, we get 58.5. I have centimeters squared here times another centimeters. Our volume is always unit cubed. So here we're going to have 58.5 cubic centimeters or centimeters cubed. Example 2 has a cylinder. So we want the cubic inch displacement. So we're looking for the volume of this cylinder. We're going to start with the area of the base. Here, because I'm talking about a circle, it's going to be pi r squared. I have the diameter as 5. So our radius is half of that, 2.5 inches. So the area of my base is pi times 2.5 squared inches. I'll give you a minute to write that down. Calculate that. You can always hit pause and come back. We get 19.6349635 square inches. The volume is going to be the area of the base times the height. So I've got my 19.635. Try not to round till the very end, but I don't want to write that whole decimal here. We're going to multiply the area of the base times our height, which is 4. Notice I didn't include the labels here. Rounded to the nearest tenth, I get 0.539, so 0.5 inches cubed, cubic inches. We have two other volumes that we want to look at this point. A cone, just what you think it is, an ice cream cone, is basically starts out as a cylinder but comes to a point on the other end. And a pyramid, same thing, a prism that comes to a point on the other end. The volume of every cone or pyramid, anything that comes to a point, is going to be 1/3 times the base times the height. So like you were finding the volume for the prism or the cylinder, and then we're going to divide by 3 or multiply by 1/3. Okay, so I'm going to start by finding the area of the base. Here it says it is a square, which is 15 on each side. So the area of that square base is 225, again, we're back in centimeters squared. The volume is 1/3 times the base times the height. So the base times the height divided by 3. We can do it that way as well. 225 is the area of the base. I have a height of 28, and I am dividing all of that by 3. And I get 2,100 cubic centimeters, centimeters cubed. Last formula we have is for a sphere. A sphere is a ball, right? A circle in 3-dimensional space. So it's the collection of all the points that are the same distance from a fixed point, not just in 2 dimensions, but in 3. And we have a special formula for volume of a sphere. It is 4 pi r cubed divided by 3. That radius now is getting cubed. And rather than doing this separate, we are going to find the area of this composite shape. Okay? And then we want the weight. If we use cast iron, and we have this conversion, so we want the weight of the solid cast iron object with the dimensions given. I am just going to go top to bottom. The volume of that cone is base times height divided by 3. Probably should not have made this line so long. Let's see if we can. Okay. If I have got, you notice down here they give me 9 inches for the diameter, which means our radius is 4.5. So the area of the base is going to be pi r squared. I'm going to multiply that by the height, which they give me as 8, and I'm going to divide that by 3. So let me give you a minute to write that. And go ahead and calculate that. We want this rounded to the nearest pound, so in the meantime, I'm going to take this out to 2 decimal places. I got 169.65. Now, I have the area of this cylinder, just base times height. It's not coming to a point. I'm not dividing by 3. Area of the base is the same. Pi times 4.5 squared. This time, though, my height is 10 inches. So I will give you a minute to write that down. And I got a volume of 636.17. Now for the bottom piece, we're going to use the formula for a sphere, but then we're going to cut that in half because notice I only want half that sphere. I want the hemisphere. So the volume of a sphere, and I'm going to write it in a way that is not going to make some people happy, 4/3 pi r cubed divided by 3. And then, well, I'm going to do it this way. I'm going to divide that by 2. So I have 4 pi. Here's my radius. It's still 4.5. I'm going to cube that, all divided by 3. Then I'm going to divide that by 2. I only want half of that. I get the volume of that sphere, if I were getting the whole thing, as 381.7. So when we divide that by 2, I got 190.85. Which means the total volume, if I add all of that together, I should probably write that. Is going to be my 190.85 plus 636.17 plus 169.65. I get 996.67. Now I need to figure out the weight. 996.67. Keep in mind that was what? Cubic inches. Cubic inches. Inches. Times, we're told the weight of cast iron, 0.27 pounds per cubic inch. So 0.27 pounds per 1 cubic inch. And notice I am writing this because I want to make sure that the units cancel and I end up with the units I want. If I multiply this, the only units I have is pounds. I get 269.1. So 269 rounded to the nearest pound, pounds. And that is it for volume. See if I can shut off the recording.